All right, next up we have George Mason, Team Data Science.
.3. Just like everybody else, we tried making a predictive model, and this is the accuracy that we got. Really bad, right? So let me explain what we tried. We tried to predict the number of opiate-related deaths by county in the year 2018 so that local governments will be able to focus their funds and resources in those specific counties. We follow the regular model of gathering data, cleaning, modeling, and then predicting the number of deaths. We used variables like prescription rate, number of people employed, their wages, other demographic data, and we used classification algorithms to build this predictive model. What we learned during this process. Data has a very inconsistent granularity. Some of the data is with respect to counties, some of it is with respect to zip codes, states. It is really inconsistent. Data does not really answer why the death has occurred. It will tell you the name of the drug, but really what really happened when the person died. It is difficult to find a common thread. We tried to use counties as our common thread to make a prediction, but you can't really find any other common factors which will help us in our prediction. And there is a great overlap between legal and illegal opioid usage. Data has been classified as deaths by prescription and deaths by illegal, but that is on the day of the death of the person. We don't really know whether that person was taking prescription drugs before moving to illegal drugs. We don't know what we don't know. Human behavior is harder to predict. Trends are area-specific. Since we all know that Virginia as a state has been divided into two parts. Some areas have more deaths due to prescription drugs. Some of them have more deaths due to illegal drugs. But we wanted to drill deeper into this. As amateurs, we were trying to predict death, and that felt wrong at some level with the kind of data that we had. We had basically structured data, Excel sheets. What we really needed was unstructured data about the people. So in trying to find a solution for the problems that we faced, these are some of the things that we realized. First of all, graphs and visualizations are much easier to interpret by the common people. People want to help with the opioid crisis. Opinions about what people think led to the death of their loved one changes. Your family, your community, your friends, your spouse are the best ones to exactly tell what led to the death of the person. Was it because there was no help in case of emergency? Was it because of depression? What was the actual reason? So we went ahead to try to find out a better answer for this, something like an app that people in general who are friends or family of these opioid users can use.
My mom tells me I ask too many questions. I disagree with that, which is the inspiration for this idea. Okay, so first things first, you've got a basic login screen. I don't know, whatever works for now. Right. So this is the basic app. Just give me a second, please. Wait, go. Okay. Shit. Okay. So let's say there's an issue that you are interested in, and think, let's say, the government or people should rather know about it. So, for example, this looks at the number of units reimbursed for fentanyl, and this looks at the number of prescriptions. So, if you think this issue is worth considering and people kind of get to know more about it, you swipe right. You think it's not worth considering, you think it's pointless, you think there's nothing useful in the data, you swipe left. That's basically about it. And let's say you kind of want to go a step further and engage. What you can do is just kind of look at all the issues that you are interested in and just basically ask questions as to questions regarding the data as such. So we have a much better idea as to what questions to answer.
We really wanted the local government to get into this.